In today's video, we are going to once again go over some problems regarding our algebra practices, and we are going to, build our algebra strength up, the thing that I mentioned in the last video. So we will be better and better, and we will go over harder and harder problems. Firstly, this is just a little bit of practice from last time. If we have we want the x's or the x expressions on one side and we want the numbers on the other side, so we can add 5 to both sides. So plus 5 and plus 5, because we want to put this minus 5 over to that side, and the way it can like sort of vanish is by adding 5. Obviously it won't vanish, that's just a metaphor, but this is 3x and this is 9, and then we only have to divide by 3. Some people like to use this one. I usually use this one because it's easier. This sign at the right side just represents that we divide each side by 3, and then we would get that x equals to 3. So this is how we solve it. This course is for people who want to build up their knowledge in algebra, but they have some foundations. Maybe you want to practice a bit or something. Or maybe you just want to quickly go over some problems. Our next one is going to be this thing. Once again, we can just subtract 10 from each side, and then we would get that 5x equals to 15, because something that we should keep in mind is that we always do the opposite. If we want to put this plus 10 over the other side, we have to subtract 10 from each side, and then we can just divide both sides by 5. So we just divide both sides by 5, and then we get that x equals to 3 once again, because this is basically 5 times x. That's something to keep in mind, and we can get 1x on one side by dividing by 5. Next one, this might get a bit trickier, but I'm sure we could solve it. Let's just zoom in on it a bit. Yeah, and great. So what can we do here? Well, we can add 7 to each side, so plus 7, and then we would get that minus 3x equals to 10. And this is when you could mess up like a couple of things. Firstly, you should definitely keep in mind that the number that this x is multiplied by is minus 3. So we have to divide by minus 3, not just 3. This is something that some people, might have a tendency to forget if they are like newer students and they just started this topic. So what that will be equal to, that's minus 10 thirds. And this is something that you shouldn't be afraid of. This is a fraction. Our solution is a fraction, but you definitely shouldn't be afraid of fractions. They are actually very friendly. So yeah, this is pretty important as well to be familiar with this kind of stuff, that our solution could very much be a fraction, because 10 divided by minus 3 is minus 10 thirds. Now this is another one. This is something that we might have not solved just yet, but it's not that hard. So we want the x's on one side, and we want the numbers on the other side, the numbers without the x multiplier, so numbers where we don't have something times x. So we could just subtract 4x to get rid of this expression on the right side. Then we would have minus 11x, because minus 7 minus 4 is minus 11, plus 5 equals to minus 13. And then we can just once again subtract 5. That's something that from this you can easily solve it. So minus 11x equals to, well, minus 13 minus 5, that's minus 18. And now we are just going to divide each side by the expression in front of the x, which is minus 11. That's what x is multiplied by. So if we want to get 1x, we have to divide by it, and that's how you get 18/11. Something to keep in mind is that we divided a negative number with another negative number, so minus divided by minus is always a positive sign, so that's plus 18/11. Great, and now let's erase our board and get on to some more difficult problems. Right off the bat, we will have something which is definitely like a more difficult thing, because now we will have two variables. We will have y, and we will have, let's say, x, and we would like to get 1x here. So what's x equal to? This is like a great thing to represent, to just show you something. So this like 0.5 can be written up as 1/2, and if we want to divide by 1/2, we basically just multiply by 2. So we have to multiply each side by 2. So if we multiply this side by 2, we will get x, which is great. You should that's how it should be. And in the other side, sometimes I even put out some parentheses like this, because a lot of people might forget that they might just say that this equals to, well, 6 plus y, because we multiply 3, but this is definitely incorrect, because we multiply the entire side by 2. So that would be 2 times 3 plus y, and it gives the parenthesis. So this is very important, that whenever because you multiply the entire side, then you multiply the entire side as well. So you can't just multiply 3 or multiply y. You gotta do it with both. And now usually some tests like this will want you to expand this, so that's sorry, no x here, because 6. I wanted to write a plus sign, so that's 6 plus 2y equals to x. And some people might get confused that why is there like a y in there, but that's completely all right. You can have another variable as a solution, because the task was to find x, and we successfully did that. We found the value of x. Great. Next problem. Today I'm just kind of speedrunning these ones, because I both don't really have that much time, and I want to make this a quicker video. Sorry. Next up we will have something once again looking like this. So we have 2 minus 3x minus 5y is equal to, let's say, this thing. And now let's say we want to find z. So what's z here? Great question. Now this multiplier in front of z, the number that it's multiplied by is 1/4. So if we would like to get z, we would have to multiply each side by 4, because we basically multiplying by 4 basically means dividing by 1/4, because it's the reciprocal of 1/4 of 1/4. So that's gonna be multiplied by 4, and once again, don't forget that this entire side is multiplied by 4. So on the right hand side, we only gonna have z, which is perfect, because that's what we wanted originally. And in the left hand side, we will have 4 times this entire thing, 2 minus 3x minus 5y y minus 3x minus 5y, that's equal to z. And then we can just expand it. So something that if you don't know that it will make your life a lot harder. Something that you might have already noticed is that we have a thing called a distributive property, which is just a fancy name for expanding this expression in the parentheses. That basically what we do is that we have 8. We just multiply everything with the number in front of the parentheses. So we will have 8, then we will have minus 12x, because 4 times 2 is 8, 4 times minus 3x is minus 12, and 4 times minus 5y, that's gonna be minus 20y. There we go. And this is actually our solution. So we will have minus 20y. There we go. That's gonna be equal to z. Right, so we have solved this one as well. Now let's see something a bit similar but yet a bit different. And this is probably our last one for today. So if we have something like b divided by 3 plus a divided by 3 equals to c divided by 3. Now this is something that you could and our question is what is c equal to? And this is like a problem that we could probably solve, because it's pretty obvious. So all of these numbers are divided by 3, so we have a pretty easy job, because in the right hand side, if we want to get c, we have to multiply the entire right hand side, which is only this one expression, by the way, by 3, and we have to multiply this side by 3. And because it's a sum, so because it's something plus something, we will do this. Now, and this will be equal to c. Now, something about this, like plus and minus and this distributive property that we talked about earlier, is something that you should definitely keep in mind. Is this thing, this like multiplying the b thirds and a thirds, both of them by 3, is only working because it's a sum. So if we have a plus b multiplied by x, then we will have, this is just a general term for doing this, ax plus bx, because we'll multiply both of them. Now on the other hand, and this is something that some students get wrong, so based on this one, we will have a pretty easy job, because this is just b, and this like the line of the fraction means that is divided by 3, and then it's going to be multiplied by 3. So we divide something by 3, then we multiply it by 3, so those two just cancel out each other, and b divided by 3 multiplied by 3 is just going to be b plus a, because we do the same thing with this a thirds equal to c. That's our solution, and we did this distributive property. However, if we would have a times b, this is something that like this is a very big red exclamation mark, like this. Like, it's very important that right now, however, you can't do that, because this equals to just x times a times b, because they are just all multiplications. Yeah, it's good. Yep. So this is only equal to this one, and that's something to keep in mind. We rewrite this a because it got pretty early, so this is something that's very important. So it only works with sums, and obviously it does work with differences as well. So a minus b. With this one, it's gonna be ax minus bx. These are like multiplied by each other, so I just usually we don't say it, but it's a times x plus b times x, and a times x minus b times x. And of course, as we saw, like if we have something like let's say something like x times a divided by b, then of course it's definitely not the same as doing the a minus b and a plus b, because then it's going to be, so we have the parenthesis here, so it's just going to be a divided by b, because we must do this first, and we can't really open it or anything, so it's gonna be just something divided by b, and just gonna multiply it by x. So that's something that we should definitely keep in mind, because most students just see a form of doing something, like a way of thinking or something, and they just get really used to it, and they apply it to more things that is legally applicable to. So that's just a little side note there to keep in mind. Now our last thing for today is saying that if we have, let's say, once again we are going to have some fractions here. Let's go with this is a pretty common one, so we will have a, b, and c, and once again we are looking for c. And now something to keep in mind is now we can't really just multiply the entire thing with one number, because the denominators of each fraction are different. In fact, if all of those would be divided by 3 or by 5 or by 6, then we would have a pretty easy job. But right now we don't really have an easy job, because all of those numbers have a different denominator. So what do we actually do? Well, it's going to be a thing called expansion, which you might have heard about when you were studying at, I don't know, fourth grade or fifth grade or sixth grade, probably fifth grade most likely, about fractions. So when you were studying about those, you do probably remember that if you wanted to, let's say, add them, you can't really do that because they are in different forms. So we need to find the smallest common multiple of these numbers, or the least common multiple, however you would like to call it. And then we would have to expand each of these expressions to that. So what's the least common multiple will be of these numbers? Well, you can think about it for a bit, but it's going to be 30, because all of those numbers can be, all of those numbers go into 30 a whole number of times. So 5 goes, if we divide 30 by 5 we get 6, if we divide 30 by 3 we get 10, if we divide 30 by 6 we get 5. Now that we established that one, it's going to be 5, and all of those need to be 30, so 30 divided by 5, that's 6. So we have to, so all of them needs to be like 30 on, like we want 30 on the denominator with all of these fractions. So if we originally had 5, then we have to multiply it by 6 to get 30, and with a we are going to do the exact same thing, so we are going to multiply it by 6 as well. Now with 3 we need to multiply 3 by 10, and there's b, and we need to multiply b by 10 as well. So basically we just multiply the numerator and the denominator by the same number. This is called expansion, because if we do this, the value of the numbers don't change. However, they will look differently, and we want them to look differently, because that's how we could solve the problem. Now 30 divided by 6, that's 5, and we multiply c by 5 as well. So now all of these numbers have 30 in their denominator. So that's 30, that's 30, that's 30, because we expanded them. And now we can just multiply both sides by 30. So on the right hand side we are going to have 5c, because let's see, times 5 is basically 5c, and we multiplied by 30. And if you remember the rule that we had earlier, you realize that we will have a times 6 or 6 times a, however you want to call it, plus we will have 10 times b. Yeah, so 10 times b. Great, so we have a times 6, 10 times b equals to 5 times c. And now the only thing that we have to do is get 1c, because right now we have 5c on the right hand side, so we have to divide with 5. And once again, remember that this entire thing is divided by 5, so not only one of the expressions. That's something that you should definitely keep in mind. So you can basically do one of two things. You can say that this is 6 times 6a plus 10b, and we just make it a fraction once again and divide it by 5. That's gonna be equal to c. So this is definitely one way to approach the problem. Or you can even divide both of the numbers by 5. So you can say that if we divide this by 5 plus, this is just a little side note, this by 5, we will get that that's going to be equal to, well, this is pretty easy, the b expression, because we will leave b alone and just say that's 2b, because these get simplified. And on the other side, we can say that, well, that one's a bit trickier, because 6 divided by 5, that's 6/5, and 6/5 a times a plus 2b. So this is also a possible solution. If we would have gotten something like 20a, then this would be a lot more obvious and self-explanatory, because then we could just write it like this, and this is a more preferred and simple form. But anyways, thanks for watching, and study some maths at home or something, because this is like the baseline of maths and the entire algebra. This is like a pretty important topic. So have a nice day.